A necklace is appraised at $5,000. The value of the necklace has increased at an annual rate. And this table shows the average yearly value. So in the year, it has an average yearly value of the necklace, okay? So in the year zero, okay, it was worth how much? Well, it was appraised at $5,000 before it went up at all. After 5 years, this is the value, over $6,000. 10 years, it went up to 8,000. 15, it went up to 10,000. 20 years, it went up to 13,000. So it looks like after 20 years, it went up at about 8,000 or $9,000. Okay. All right. Now, what type of function best models the given data? Is this a linear function with a negative rate of change? Is a linear function with a positive rate of change? Or maybe it's not linear. Maybe it's not linear. Maybe it's exponential and it's decaying, or exponential with growth. All right. So which one of these four is it? Well, if it's linear, a line has something we call slope. Okay. And let's look at the value after 5 years and then subtract the value for 0 years. When it was appraised in the year 0 at 5,000. So this went up about $1,000. Okay, about $1,381.41. Now, if we go from 63.81 up to 81.44, let's write down the 81.44 and subtract the 63.81. This is the value at 5 years and 10 years. Let's see what it increased. Okay, 7 minus 1. Don't forget your decimals. 7 minus 1. 4 minus 4. 4 minus 1 is 14 minus 8. And when you borrowed 1 from this becomes a 0. So we have 10 now. 10 instead of 11, it's 10 minus 3. And then we borrow 1 from here, made 7 minus 6 is 1. So now it didn't go up $1,300 like it did last time. It went up more. These changes are different. Well, to be linear, you have to have the same change. Okay? It should be the same change. So we're eliminating the first two because the change was different up here. The change is different. We eliminate the lines, the linear ones. We don't have a certain slope. It changed. So now either we have exponential decay or exponential growth. Okay. Now decay means the value is going down. It's losing value. Well, we can clearly see that's not true. So our answer is going to be exponential growth. Exponential growth. Let's graph these points here. Let's get a set of axes here, and we'll graph 0, 500. Where's that going to be at? 0 here, go up to not 500 but 5,000. Okay, this is the point for this ordered pair. Now how about the point 5, 6,000? 5, 6, 3, 8, 1. Where's that going to be at? Come over here to 5 and go up a little more than 6,000, somewhere in there. Okay, now go to the 10 and 81, 10 and 8,000. Come over here to 10. Go up a little bit more than the 8. So you see, count with me. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,100, somewhere in here. And then we're going 15 to 10,000. 15, go up 9. That's 9. Go up to 10. And about a third of the way in between those two. And go to 20 and 13. Here's 20. There's 10. 11, 12, 13, a little more than 13. Okay, so these are my points drawing the curve. You can see it's not linear, can't you? Okay, you can see it's exponential. That's a graph of an exponential function. And the value is going up. I already told you the answer was D, but the graph ought to help you see it's not a line. If it were a line, it would be going up the same amount each time. A line would be going right through here. It's not a line. You can't draw a line through those points. So we're going to say it's growing. The amount is growing. It's going up after 20 years. Went up $8,000 from 5 up to 13. Went up. It grew. Okay? Answer is D.